Hello friends, in this video we will see the preliminary design of the beam. So preliminary design of the beam. So similar to the slab, what we do is the effective depth D here is shorter so span of the beam, so not the shorter span of the beam divided by 12 to 15. So in this condition, which beam should you take? You should take the longest beam. So here if we see the AutoCAD drawing, you can see that this beam or this beam is these two beams are the longest beam here. So why do we take the longest beam, or why did we take this biggest slab? It is because if a certain slab size or certain beam size satisfies these larger beams, in that case that size also will satisfy the smaller beams. So that is why we take the largest one. So let's take this one. So 13 feet and 6 inches, that was equal to how much? 4.11 meters. And let's divide 4.11 by, so it's 4.11 divided by, let's take 15, and so effective depth D of the beam is equal to, so let's use the calculator. Okay, let's go up. So this is where we converted the size. Let's do is equal to, now it has this value has been saved as the answer, and if we divide this by 15 and if we multiply it with 1000, so it's 274.306 mm. So okay, so 274 mm, and if we divide it by 12, let's do it by 12. Okay, is equal to, divide this answer by 12 into 1000. If we do, we get 342 mm, that is nearly equal to 350 mm. So in a residential building, generally the size of the beam is taken as 350 by 230 mm. So once you practice, you will know this, and you have to take your value closer to that. We'll divide it by 12, and we'll get something 342 point something mm. Okay, mm. So this is in meters, and we'll take nearly equal to 350 mm. One thing that I forgot to tell you in slab design is that, so we got the effective depth as D. Okay, the overall depth turns out to be overall depth for both the slab and the beam. The principle is same. D is equal to effective depth D plus, you have to add the half of the rebar plus the clear cover. Okay, because this is your effective depth, you add half of this rebar, and after that you add this clear cover. Okay, so this portion, and if you do that, you will get the overall depth D. So here the effective depth, if we take, okay, so try to make your overall depth nearly equal to 350, because that is generally the size of the beam taken, and it is easier to work out. And if, however, in the design, while we are designing the building, we find that this size is not sufficient, the beams will fail. In that case, you can increase the size, but for the time being, should start with 350 mm. Don't go with sizes like 360, 370, and that might be a bit hard to work at the site. That might be surprising for the workers to work at the site, because they are used to the usual sizes. So let us suppose that let us take effective depth D as 300 mm and half of the rebar. So let us assume we will be using the rebar of 16 mm. So 16 by 2, it's 8 mm, plus clear cover for beam is generally 25 mm. So this is 300. Okay, so 300 plus 8 is 300. So 300 plus 25 is 325, plus 8 is 333 mm. So let's take nearly equal to 350 mm. Okay, so this is how you do it, and similarly you have to change the factor here as well. And for the slab also we can do the same. This is just a thumb rule, and it is not hard and fast rule. So we got the overall depth of the beam as 350 mm. Now what we're gonna do is we'll find the breadth of the beam. Okay, so breadth of the beam B is equal to D by 2 by 3 of D. So let's take a 2 by 3 of D is equal to 2 by 3 into 350, which is equal to, so if we do it using the calculator, okay, so 2 divided by 3 into 350 is equal to 233. Okay, and so 233, and let us approximate it to 230 mm, so that is 9 inches. So this is how you find the breadth of the beam. And one thing that I need to tell you is that, so if this is your beam, and if we say that the depth of this beam is overall depth is 350 mm, which means that the depth of the slab is included. So if this is our slab, this is the slab, and this is the beam, so 350 mm is from here to here, 350 mm. Okay, and the depth of the slab, that is 100 mm. This is 100 mm, and this is the breadth of the beam. And you can see this thing in the section of the our structure as well. So if we see the section here, and you can see that, so from here to here, so this is the section, right? So this is the slab. Okay, so from here to here it's 100 mm, from here to here it's 100 mm. So this is the size of the slab only, and the depth of the beam is from here to here, not here. Okay, from here to here it is the depth of the beam.